Welcome to the AI-powered software testing platform with Fadi Othman, Gilbert Keithline, and Jin Huang. My name is Gilbert, and I'm excited to take you on a tour of our Spring 2025 Capstone project. This project was proposed by Dr. Roma Schusterman of the Brain Electrophysiology Lab located in Eugene, Oregon. Fadi was our primary pipeline and orchestration module architect. I handled large language model integration and was the primary LLM prompt author, and Jin was our primary validation engineer and oversaw agile project management. This project was developed under an NDA. As such, we will not be showing any code snippets in this presentation. However, we have been cleared to show our pipeline in action, as well as examples of output. Our project is an AI-powered testing platform that automates the entire QA workflow from pulling in requirements to generating executable tests. Our project will tremendously speed up release cycles and boost coverage and consistency of QA workflows. This project is being developed in two parts. We are Group A, and we are responsible for requirement intake and test generation. We implemented a pipeline through a GitHub action workflow. Upon a new software release in GitHub, this test pipeline fetches corresponding requirements from Jira, feeds them into Anthropic's Claude AI to generate comprehensive test cases, automatically validates each case for quality control, and then generates a Playwright test script that can be executed in continuous integration, laying the foundation for end-to-end development. Our pipeline takes a few minutes to complete a run, so before proceeding with the presentation, I have prepared a demo to run in the background. For our demo, we will be deploying version 1.0, a simple user login feature. And if we go to our Actions tab, we can see that the pipeline is being initialized. We leverage LangChain.js framework and Claude to turn a JSON file of Jira requirements into a positive and negative test case file and TypeScript Playwright tests, which are gated through our validator for comprehensive rule enforcement. Once the pipeline has completed its run, all fetched Jira requirements, AI-generated testing material, and validation results are automatically uploaded to a new branch of the repository for review and archival. Let's take a closer look at what each team member contributed to the project, starting with Fadi. Fadi worked on Jira API integration to pull completed requirements for each version release. He built GitHub integrations into the pipeline to automate branching, file commitment, and pull request generation. He developed the GitHub Actions workflow that triggers automatically when a new software version is released, and he created a demo website using React to test and validate the Playwright scripts generated by our pipeline. Fadi's tech stack included TypeScript as his main programming language, the Jira REST API and Axios to retrieve requirements programmatically, Postman to help test Jira API responses, the OctoKit API to interact with the GitHub repository for commits and branching, GitHub Actions to automate the test pipeline, and finally the demo website was built using React and Mantine for quick UI testing of generated test scripts. For Sprint 1, Fadi was responsible for writing a JQL query to find all of the completed requirements for a software version number in Jira, and then parse those responses into an LLM-friendly JSON. For Progress Report 2, Fadi worked on GitHub integration using OctoKit to create branches in GitHub for versioning and committing files to the repository. He also created our GitHub Actions workflow for the test pipeline to fetch requirements and generate test cases. By Sprint 3, we needed a target app to validate the test scripts, so Fadi deployed a simple website with basic user actions based on test Jira requirements. He also enabled the pipeline to create a pull request at the end of the pipeline run for review of the results. Finally, he integrated the generated test scripts into continuous integration so we can see the results right away. Fadi followed the project plan for the major requirements and did not have any major deviations from the original plan. Some items were handled earlier than they were originally planned for, like versioning and error handling. The biggest problem Fadi had was handling the response from Jira's API, as it came back as a nested set of items that required careful parsing to accurately store the desired data. Using Postman helped visualize and parse the responses. Another challenge was giving Claude the right context to generate effective Playwright scripts. Fadi and I worked together to refine the prompts and ensure Claude could reliably identify and interact with UI elements on our test site. During our project, Fadi learned how to integrate multiple APIs into one system, use GitHub Actions effectively, and write better prompts for LLMs. It also strengthened his teamwork and planning skills. Now let's take a look at Jin's work. Jin built and managed our Agile Jira board, and she also authored our test case validation guidelines and developed both single file and batch validation scripts, which she then integrated into our CI/CD pipeline. Jin's tech stack also relied on TypeScript and the GitHub API with OctoKit. She introduced the fast Levenstein library to enforce validation rules. During Sprint 1, Jin established our Jira project management board and developed the guidelines that would go on to become the foundation of our validation process. For Sprint 2, Jin built a validator script that runs on a single Jira file of LLM-generated test cases, and then upscaled it into a batch validator that runs across all cases generated for a version release. During Sprint 3, Jin expanded the rules enforced by the validator, upgrading the batch validator to provide full coverage checks, and then integrated the validation script into our CI/CD pipeline. Jin's original project plan featured system-level test coverage, but that target was ultimately deprioritized to focus on the more relevant pipeline validation module. System-level coverage is expected to be developed by a subsequent team once parts A and B have been successfully combined. The greatest challenge Jin faced was designing and deploying a project-scale validation plan in a fast-paced startup-style environment. Breaking the specifications into checkpoints and collaborating with me on LLM output expectations and structures helped alleviate this. Throughout this project, Jin strengthened their already considerable skills as a researcher while also building a foundation in TypeScript and gaining exposure to a CI/CD pipeline in a startup-like environment. Which brings us to my work. I handled research of LLM APIs, integration of the LLM module into the pipeline, and was our primary LLM prompt engineer. My tech stack used the LangChain.js framework to harness Anthropic's Claude AI model for generation of test cases and Playwright test scripts in a series of TypeScript apps. My Sprint 1 focused on LLM research and comparisons and development of an LLM client app and prompt combo for test case generation. During Sprint 2, I shifted into dedicated prompt engineering and worked with Jin to ensure our test case output consistently met validation requirements, resulting in a much stronger prompt and output format. During Sprint 3, I developed a variant of the test case generator that reads a JSON of generated test cases and generates a fully deployable script of Playwright files exported as a TypeScript file. I then worked with Fadi to integrate the LLM module into our CI/CD pipeline. I was able to meet all expected deadlines without any significant deviation from the project plan. Some tasks were completed ahead of schedule, such as test case generation and integration into the pipeline. The greatest challenge I faced was a complete lack of exposure to TypeScript, which I largely learned on the fly. Thankfully, a series of TypeScript and LangChain tutorials were able to bridge the knowledge gap. Fadi also reported multiple instances of the test output being cut off mid-script. We couldn't return the scripts as a JSON due to formatting, like we did with the test cases, so I had to set up a data stream to return the script as a string through multiple packets in order to get all of the information. By the end of this project, I've developed a strong foundation in TypeScript, become familiar with AI-powered application development using LangChain.js, and I've learned how to engineer strong prompts that leverage the full capability of a large language model, all while gaining valuable experience using GitHub's CI/CD tools as part of a live development team. And now let's go have a look at the pipeline that we triggered at the start of the presentation. So here we can see that the pipeline has successfully run, and we'll just click out of all these setup steps. And here we have the first impactful moment, requirement fetching from Jira. As we can see, we got a user authentication feature from the Jira API. We then generated test cases using Anthropic's Claude. These test cases were successfully validated, all passes. And a TypeScript testing suite was built using Playwright. And finally, a pull request was created, and all of that information was saved to a tidy new folder on its own special branch. And if we come up here to our actions, we can see that the Playwright tests were also successfully deployed. And all 5 generated tests passed. Over here we have an example of our demo website. The generated Playwright test scripts use this website to test out requirements from Jira. We have 3 features. The first is a user authentication feature, which we have right here. and this is what our tests were running against. If we have 3 failed login attempts, the account is locked out for a few seconds. If I refresh the page, it'll remove the lock for demo purposes, and then I can enter valid credentials to log in and be redirected to the dashboard. Here we have a simple counter feature where the user clicks a button to increment the counter and the text is updated accordingly. Likewise, I can click the reset button to bring the counter back to 0. And here we have a filtered search page where the user can search for fruits that match a search query. If no matches are found, then the search results indicate that here. I can then click the reset search button to clear the search history. Here we are on our main branch, and we can see that the versions folder has just the test 00. But if we go to this recently created version 1.0 branch, we can come down here to versions, and we'll see a new version 1.0 where we have the JIRA requirements that were successfully fetched. We have the test cases, both individual and a batch file. And we have the AI-generated TypeScript testing script. And now here we are at the conclusion. Moving forward, our codebase will be documented and archived for continued development by a future Capstone team. If a developer is watching this video with the intent of picking up our baton, we believe that integrating access to the source code of the web apps under test will greatly improve the scope and reliability of the generated AI test scripts. We are very satisfied with the strong proof of concept that our efforts yielded this term, and look forward to seeing our pipeline deployed on a live application someday. Thank you again to our sponsor, Dr. Roma Schusterman, as well as our awesome OSU instruction staff for the opportunity to work on this project. It has been our pleasure to share it with you.